the basic objective and scope of computer graphic. We have seen why do we need computer graphic, what are the applications of computer graphic, what are the main classes or the main API that we can use in Java. We have the Java 2D class and the Java 3D graphic system. Okay, so to understand the evolution of graphic programming environment. So here we see the evolution of the graphic programming environment. We start from the low level programming language till the high level or platform independent programming with Java, Java 3D and Java 2D. Okay, we'll identify the common graphic API. So here we are talking about graphics 2D and graphics 3D. We'll see the role of the Java language and the role of Java 2D and Java 3D packages. Okay, and we see how to make graphic with Java. We have a skeleton. We'll open the skeleton. So there is a skeleton that you have to upload from CLMS. And this will be the skeleton of all the programs that we see in this course. Okay. And then you have to identify the graphic related fields. So here we have an explanation or just what does mean computer graphic and when do we use computer graphics. So here we are talking about the graphic user interface, how to visualize data, how to generate realistic images, realistic sequences of images, videos, games, etc. Okay. So here we have seen from real scene to an image. So here, generally, we have a ball here that you want to display. So first of all, we have seen that you can make some approximation. For example, you can make an approximation that the ball here is half of speed, for example. This is the first approximation. And here we have an oval. So by making half of oval and oval, we have done with the ball. And here you can see that here we have just a rectangle. So we did here an approximation to simplify the design. So now we have just three shapes, and these three shapes, they are well known, and we have the equation. We know the equation of every shape. So it doesn't take a lot of memory in the computer. Why? Because we made an approximation to simplify the design. Then we have to make projection from 2D to 3D. So here we are talking about the rendering. If you want to make a rendering here, generally we are designing 3D object, and then we have to show to the user just the 2D view. So here in the rendering, we are making from 3D to 2D projection, and then we can select one part of the space of the workspace. So here we are making the clipping, or we are taking just this part of the image. So the output here is the 2D image. So here we have just an example how to make the modeling and the rendering. So generally we have two types. We have two tasks in computer graphics. The first task is the modeling. So here we are creating a virtual world. So here we have this virtual world. This is our environment. So here we can create, for example, a cylinder here, box here, stars, etc. So this is called the virtual world. Okay, so the virtual world, we are talking about virtual world, or we call this also the world space. And then from this world space, we have to select a point of view. For example, we have a camera from this side. So here we have to select the view. So to make the view, we are going from 3D to 2D. And this is the rendering. So the rendering here is just a 2D view of the 3D workspace or world. I can show you some examples so that you can understand. I prepared some slides. Rendering. Please mute your mic, Shabab. Try to mute your mic. Okay, so here I prepared some slides for rendering. So here you can see the difference between the modeling and the rendering. So here to the left, we have here the 3D model. Okay, so you can see that to create this 3D model, we made some simplification. So here we are using some polygon to create this model. So these are the polygons that you are using to create this model. So we are combining the different polygons together to find the 3D model. And then here we have for the rendering, and we can see the rendering here. So you can see that in the rendering, we are taking just one view of the 3D object. You can see a 2D image. Okay, so it is 3D rendering, but it is presented as an image, and the image is the 2D image. And you can see that here we are applying here a texture, which is a metal texture here. It is a copper or gold copper texture. Here we are applying lights. Okay, so when you change the camera or the position of the camera, we are changing the view. Is it clear the difference between the modeling and rendering? So we are adding also background images, etc. So here we have another example. So here we have the modeling, and here we have the rendering. Same thing here. We have these three models. We have the modeling, and you have the rendering here. So you can see that we are applying lights. We are changing the position of the camera. We are adding some materials. We are adding background images, etc. Here we have another example. So here you can see the design or modeling here in all this area. And here we have an example of rendering. So you can see that we are applying some texture here. For example, you can see that we are applying texture. Here we have the cabinet without texture. Here we are applying the texture. Same thing here, we are applying a texture, which is this texture, etc. Okay, so this is what does mean texture. You are applying the texture. So here you have an image, and you are copying this image in all this area. This will give us this effect, which is the texture effect. Okay, so here for this glass window, we are applying here an image. So you can see here the rendering of the image. Here there is an image. Okay, so here you have, so in this part, you have the design, modeling, and here in this part, you have the rendering. Is it clear the difference between modeling and rendering? Try to use your mic to answer, please.
Yes.
Okay.
Yes.
So here we are moving from 3D virtual word model or word space. We call it word space or word model or virtual word model. And then if you make the rendering, we are just taking a scene here, or taking just projection from the 2D from 3D to 2D to create just an image, or we call it also a scene. Okay. Now we have seen in the previous example that to create a model, generally we are making some approximation. Okay. For example, here we have an approximation by using polygon. So what type of polygon here? By using just triangle. This is the polygon that you are using for modeling here. And the number of edge in the polygon depends on the shape that you want to model or to design. Okay, so here we are using modeling by using here triangle. In the previous example, we have seen how to make model by using another type of polygon. So here we have a modeling. So here also we have a polygon, but the polygon here has 4 sides, and the polygon that you have in the slides has 3 sides. Okay, so here the selection of how many sides you have in the polygon depends on the shape that you want to model. Okay. Now, if you have to model shape, so here you can select the polygon. Okay, and if you have a polygon here, for example, this polygon. Now, how to describe this polygon here? So we can describe this polygon by getting or by giving the point here. Let's suppose that we have P1, P2, and P3. So here, these points, they are called vertices. So the vertex 1, the vertex 2, and vertex 3. So we can describe the whole geometry by giving the list of vertices. For example, let's suppose that this is our shape. Here Q, And here we have a point B8 here. Let's suppose that this is our shape. So how can we define this shape? So here we are modeling the shape by using polygon, and the polygon that we are using are triangle. Okay, so we can describe the shape, but by giving the list of vertices. So here we have the vertex 0, this is V0. How to describe V0? V0 here is the intersection of the face 0. So this is face 0. Intersection of face 1. This is face 1. Okay. Intersection of face 12, which is at the bottom of face 15 and face 7. So the intersection of all these three faces will give us the vertex 0. Let's do the vertex 5. It is, so we can see all the faces. So for the vertex 5, how can we define the vertex 5? It is the intersection of this face, which is face 0. Now we have the face 1. This is the face 1. Face 2. Please mute your mic. We have face 9. And we have also face 8. So the intersection of these faces will give us the vertex. So we can describe the whole shape by giving the list of vertices. It is very easy, and we can describe this shape by using just this table. Or we can describe the list of faces. We can have the faces list. So here we have face 0. What is face 0? Face 0, it is here. It is the intersection of what? Or how can we draw this face 0? So the face 0, the limits of the face 0 are the vertex 0, the vertex 4, and the vertex 5. And for every vertex, we can give the 3D coordinates. So if you have vertex 0, so the vertex 0 can be a vertex or a point with the value x 0, y 0, and z 0 are in 3D space. For every vertex, we have the 3D coordinate x, y, and z. For the vertex 1, we have x1, we have y1, and we have z1, etc. So you can see by giving the list of vertices or the list of faces, we can describe any shape that is modeled by using polygon. Any question about this? Okay, sometimes it's hard to use polygon to describe some shape. For example, here for the hair. So you can see that we don't have shape, we have like lines. Okay, so to model, for example, hair, fire, curtains, etc., we are not using polygon, but here it's better to use spline. Spline here, we have a line, and we can give the equations of these lines. So we can use spline, or we can use polygon to make the model. So we have seen this example in the previous class. So here we are modeling a rabbit by using triangle. So what's the difference between the first rabbit and the second rabbit here? So you can see that in the second rabbit, we have more details. In this rabbit, we have more details, etc. So here, what's the advantage of having more detail? We have here good quality of the image. But here we are increasing the complexity. If it is a video game, if you give more resolution, if you are increasing the resolution, you are also increasing the complexity of decoding this image. So here there is a trade-off. So which mesh you have to use? You can use this mesh, or you can use this mesh. So it depends on the application that you have. If you need more detail, you can refine your mesh to find more details, and this will increase the complexity of your image. So here there is a trade-off between complexity and the resolution of the image. So the process of reducing the complexity, which is the number of polygons of the scene, in order to improve the frame rate. So here, to reduce the complexity. So if you have a video, for example, if you have a high details, if you have high resolution, this will decrease the frame rate. If you have less details, you can increase the frame rate. Now, common vocabulary. So I've seen this in the previous class, but let's do it quickly. So the graphic object can be in 2D or 3D space, and in Java we use Java 2D and Java 3D APIs. So the common space to hold all the graphic object, it is called the word space. So here, if we turn back, so here we have the virtual word model or the word space. It is the place in which we can put all the objects. So in this model, we have some object. For example, this cylinder is an object. This cube is an object. The star is also an object. So where to put all these objects? In the word space. So the graphic object can be modeled in the word space. So generally here we are talking about geometric entities. Like, for example, lines, surfaces. We can have rectangles. We can have ovals, etc. Okay, we can have lights, we can have camera, we can have text, we can have also images, etc. And for these objects, you have some properties, like, for example, the color, the transparency, the texture, etc. So if you return back to the previous example here, so for this object here, you can see that we are using a color like this for the texture, or here a metal color for the rendering. So here we are using metal texture, okay, for the rendering. So first of all, we have our virtual word or the workspace. In the workspace, we will create some objects, some 3D objects, okay. And for every object here, so here we have object. And for every object, we have some properties. Properties can be color, can be transparency, can be the texture, etc. Okay. And then we can use the render or the renderer to design or to make the rendering of the scene. So you have 3D space, okay, and from this 3D space we need just one view, one scene. Okay, so here it is called the rendering. So this process, it is called the rendering process. So by using the modeler, we are making the construction of the virtual world by using the modeler. And by using the renderer, we are making or we are rendering the scene or are generating the scene. Okay, any question about this? Okay, once we have done with the modeling, sometimes we need to make some transformation. And for the transformation, we have two types of transformation. You can apply transformation on the whole workspace. So the whole workspace here, for example, if I make translation to the whole workspace, so the whole workspace will make translation or rotation. So it is a 3D, so it can make rotation, translation, etc. Or we can perform an operation of transformation on the object. So if you are transforming just one object, it is called object transformation. And if we are transforming the whole world, the whole 3D space, in that case, it is called viewing transformation. So we have two types of transformation, the object transformation and the viewing transformation. So the object transformation is the mapping of the object into the workspace. Yani where to put your object into the workspace. So if you change, if you make an object transformation, you are just modifying the object. But for the viewing transformation, it is the transformation from the workspace to the device space. That means here we are changing how to create the scene from the object space or from the workspace. Okay, yani if you make transformation, if you make viewing transformation, let's suppose that this is our world, this is our workspace. If you make translation, for example, like this, we are translating all the objects. We are changing the viewing point. So here we are viewing, we are making the rendering in the device space. For example, let's suppose that the device is the screen. Okay, so the transformation that you are making can be seen directly on the screen. Okay, and generally for the transformation, we are using geometric transformation, and most of the geometric transformation are affine transform. Okay, so the transformation that you can have can be translation, can be rotation, can be scaling, can be reflection, can be shearing, etc. These are the transformation that you can have. Is it clear? Object, so you have to know what is the difference between object transformation and viewing transformation. So in today's class, we'll see an instruction that permits us to make a viewing transformation. We are transforming the whole word space. We are making translation of the whole word space. So all the elements will be translated. If you make object transformation, only one object will be transformed. Now, if we are making rendering here, we are generating the view. Okay, so the view is used to see the model in the virtual world from specific perspective. So you can have 2D view and you can have 3D. Okay. So the 2D view is sample, and here the viewing transformation is undistinguishable from the object transformation, because here we are talking about 2D objects. And the rendering feature, like as composition rule, clipping, path, etc., can be applied. So we'll see these transform in the next slide, inshallah. Okay. And for the 3D view, it is more complicated. It's like camera. So it's like changing the point where to place your camera. Okay. So it involves projection process that maps 3D object to a 2D. So here we are talking about projection, viewpoint, orientation, field of view. So all these, they can affect the 2D rendering. So if we summarize, we have 2D rendering and we have 3D rendering, and this is to generate the viewpoint, to generate the scene. Now let's talk about the hardware. So for the hardware, we have input device and we have output device. So the output device can be used to display the graphics. So output device can be a video monitor, like the screen, can be printer, can be plotters, video projectors, etc. And the input device can be mice can be joystick, can be tablet with pen, etc. And also the capabilities of the hardware device have a great impact on the graphic system. So if you want to play, for example, a video game and you don't have a powerful graphic card, you cannot have a good resolution. Okay, so here the characteristics of the hardware device affect or has a great impact on the graphic system. Now, once we have done with the design, you can add some interaction. You can have, for example, an animation. Is an animation. So we designed it here, we made the modeling, and then we made the rendering, but we will not make one rendering, but we will make one rendering at a time. So in that case here, we have to add the time component, and you have an image every time. So how many images do we have per second? It depends on the standard that you want to use. You can have, for example, 30 frames per second. You can have 24 frames per second. So it depends on the standard that you are using. Okay, so in the animation, instead of having still image, here we have a dynamic graphics. Dynamic graphics, that means you have many images. Okay, and you are showing these images one after. Okay, this is for the animation. We can we have a chapter for the animation. You can have interactions, like for example in graphical user interface. In graphical user interface, we have already the graphics, but when you click on a button or when you change the position of the mouse or whatever, here we are making an interaction. There is a response to the user input. So the user can make any change as input, and then there is a response to this. Okay. So as an example of interaction, we can have the graphical user interface, we can have the video games, etc. Now let's talk about the different environments of graphics. Okay. So there are many levels, there are many layers of graphics in the computer. We can have here graphics in hardware. Directly hardware. We are directly talking with the registers, directly talking with the pixels. Okay, so each or every register will be translated by the pixel in the image. So we can have graphics in the hardware level. We can have a graphics in the operating system level. We can have a graphic in the graphic standards. So like the GKS, the FIGS, the OpenGL, and you can have a graphic in Java, for example. Here we are talking about platform independent graphics. So there are many layers, there are many levels of graphics. Okay, so here if we summarize, so we as a user, we are using, for example, Java 2D or Java 3D. So here we are using an API, and this API is using OpenGL, which is a standard. So this OpenGL, it is a platform independent library. It is open graphic libraries, and it works on every operating system. That's why here on OpenGL, so the operating system can understand this file because it is following the standard OpenGL. And then the operating system or the hardware can understand this graphic because it is given by the operating system. Okay, so here with Java 3D, so we as a user or as a programmer, we are at this level. Okay, and Java 3D is using the OpenGL. OpenGL is using here the operating system, and the operating system is using the hardware to generate the view. Now let's talk about the hardware level. In hardware level, we are directly talking with the computer, with the microprocessor. We are talking directly with the registers of the computer. Okay, so here we are how to directly communicate with the computer or to the CPU. So here we are using low-level programming language like assembly programming language. Okay, so here it is machine dependent, and you are generating the code that is working only on that machine. It is working only on that type of processor. Okay, so as an example here we have the MS-DOS graphic program. So MS-DOS is for, so MS-DOS is before Windows. So before Windows we had MS-DOS, Microsoft Disk Operating System. Okay, so here we are talking about, we are using the pixels one by one. So from one pixel, we can go here in this direction, we can go in that direction. So here we are directly talking with the registers of the hardware. So this is hardware. Then we have the operating system level. So the operating system is working with the hardware, is communicating with the hardware. Okay, so here we have a program. We can program the graphics by using operating system graphic support. We are not directly here manipulating the graphic hardware, but you are using the operating system, and the operating system will manipulate the graphic hardware. So it is portable on some platform. Okay, so here we are using a graphics API, like for example for Windows. So Win32 here is the API that we are using for 32-bit Windows operating system. Okay, so here we have, it's not portable on all the platforms. So if it is written for Windows, so it will work for all the Windows platform. It will not work for Mac operating system. So you have a problem of portability. That's why here they created some standards. And this is the next level. So here we are talking about the standard. So here the standard, the first standard was the GKS and the FIGS. So graphics programming will provide a layer of abstraction necessary for device platform independence. So to be platform independent, we have to create some standards. So the first standard here was the GKS. Okay, so here we are, we have the international or the ISO standard. This is the number of the standard. It is independent in device platform. So if you write something, if you follow the standard, GKS on the FIGS, here we are creating graphic that is device independent. Okay, so it can work on Windows, it can work on Mac OS, etc. So here we are talking about 2D graphics, and so as an example, here we have the Fortran GKS program to draw a circle. Okay, or for the FIGS, here we have the hierarchical interactive graphic system, which is the FIGS. So here for the FIGS, it is 3D, it is standard for the 3D graphics. So it is from 1991. And here 1985 was the first 2D graphics. Okay, any question about this? So here we are talking about the standards. And since we have a standard, we are here platform independent. Okay, and then we have the OpenGL environment. So the OpenGL is popular 2D and 3D graphics API derived from the GL, which is the graphics library. So here we have more than 200 functions, and it provides more powerful API than the earlier standard GKS and what is the next standard? GKS and the FIGS. Okay, so it is using here the C programming language, and the OpenGL consists of two libraries. We have the GLU and the GLUT. So the GLU is the OpenGL library. So here we have a high level of utility function. And for the OpenGL toolkit, so here we have complete graphic program. Okay, so it is a toolkit that you can use for graphics. Now for the Java uses OpenGL. Okay, so in Java we are using the OpenGL. So the OpenGL provides standard and efficient rendering interface to graphic hardware. However, with the rapid development of computer hardware and software, a high level of object-oriented programming-based graphics offer great benefits. That's why here in Java, now we have the Java 2D and the Java 3D. So Java 2D and Java 3D here, they are offering object-oriented programming tools. Okay. So here we have the graphic application. The graphic application are made by using the Java APIs like Java 3D and Java 2D. And Java 2D, Java 3D, they are using OpenGL. And the OpenGL is communicating with the operating system. The operating system is communicating with the display driver. The display driver will communicate to the graphic card, and the graphic card will communicate to the display unit. So the display unit here can be, for example, a screen or video projector or printer. Any question? Now, in this course, we will see how to make graphic by using Java. So some advantages of Java. What are the advantages of using Java? So Java is simple, it is object-oriented. Write once, run anywhere. So here we are talking about the portability. And then we have multi-thread. So we can divide the task into different threads, okay? And in Java, generally, we have two facilities that you can use in Java. We have two libraries, okay? Then we have the AWT and we have the string, and we see how to use both. Okay, so AWT is the abstract Windows toolkit. So it offers the capabilities to control a certain rendering attribute like drawing color, drawing some graphic primitives like line, like rectangles, oval, etc. So these features, they are limited. If you need more features, it's better to use the swing. So the swing is completely redesigned graphical user interface that is included in the Java 2 platform. So we see in the programs, we will use both. We will use the AWT, which is the abstract Windows toolkit, and also the swing. Now, Java programming languages. So here we are talking about Java, OpenGL. Okay, so here one graphic programming for Java, which is the OpenGL. So Java here it is using this standard, which is the OpenGL. So the two components. So here we have GLC canvas and GL panel. So these two components, they provide the drawing surfaces for OpenGL. Now let's see how to write program by using Java, how to write a graphic program by using Java. So here we have to import the packages that we need. So here you can see that we have import java.awt.stuff. So awt here we are talking about the abstract Windows toolkit. We are talking about this package. So if you want to change the color, if you want to draw rectangle, if you want to draw ovals, rounded corner, rectangle, etc. So if you want to draw some simple shape, we can use the AWT. So that's why you have import java.awt. So I can use the event. You can also use the swing. So I've seen that here. With the swing, you have more features. So swing is completely redesigned graphical user interface. So you can see that here also we are importing the swing. Okay, so here we are using random image input outputs, the exception, buffered images, etc. So here principally we are using the AWT and the swing packages. Okay, now after that we have to use here the class, the applet. We have to create an applet. So here public class Java application extends G applet. So here we have to create an applet, and in this applet we have to create a frame. Okay, so here we are using the init method here. Okay, and in the frame what do we have? So here we have to use the panel. So have the JApp1 panel extend G panel. So here we are using panel. In the frame we have a panel. In this panel here, what do we have? We have the paint component. So this is the preferred size of our panel. Okay, and then we have here the paint component, which is graphic. And then we are making a casting of this graphic to make the graphics 2D. Okay, and then we can write the code starting from this. And in the program, we will see this part, then this part, then this part, and here after graphics 2D, we can put your code here. And the first line of code here in this program will be g2.drawLine 0, 0, 100, 100. And this program will just draw a line from the first point. So the first point here, let's talk about here the device port or device space. So on the device space here, we have here the coordinate 0, 0, and here we have the x-axis, and here we have the y-axis. Now we are drawing a line from the first point. The first point has the coordinate 0, 0. This is the first point. Let's call it P1. The second point has the coordinate 100, 100. So on the x-axis, we have to go here 100. The y-axis, we have to go here 100. So this is the second point. And then we have a line for connecting P1 and P2. Okay, so this is what we call the skeleton. This is the skeleton that you have to use to create all your programs in MT240. So let's see where can you find the skeleton. So you can download the skeleton from LMS. Okay, so this is the content of the TM240. Okay, so I have unit 1, unit 2, unit 3, till the last unit, which is the unit 11. And here you have the computer graphics using Java textbook. This is your textbook. And in the CLMS, you can go from the CLMS or you can go from the units here. In the units, you can download the different skeleton. Okay. So here you can see we have the study calendar, and then you have the plagiarism policy, you have the late submission policy for the TMA. Okay, then we have the first week, which is the first lecture. So here we have the lecture, and then you have the hello world code. So the hello world code is the skeleton that you can use for the whole term. Okay. Now for the lecture, you can click here. You have to. This will give you the PowerPoint file, and this will give you the skeleton, which is here. You can see that now skeleton.zip. You can download it, and this will give you a zip file, which is this compressor. Okay, now let's use NetBeans. I'm closing everything here. Okay, let's now open the skeleton. So unzip it for skeleton. So it is this file. Let's call it here skeleton 0 test. Skeleton test. Let's open this skeleton by using the NetBeans. So file, open project. This is the skeleton 0 test. We can open the project. I can go to source package. You can go to the skeleton, and then you have the Java file. Double click, and this is our skeleton. So what do you have here? We have the different packages. We are importing the AWT. We are importing also the swing. Okay, and then here we have the Java applets, we have the Java panel, and we have the paint components. So if you want to write any code, any piece of code, it will be after the paint component. And here we are supposing that the program starts here. And in the exam, you don't have to write all the packages here and frame, the applet, the panel, etc. So you can write your code starting from here. So here we have the code just to draw one line from the position 0, 0 to the position 1, 200, for example. Okay, so let's use the plan. Let's run this code. So you can see that you have this panel. In the panel, as I said in the previous class, you have the coordinates. So you have 0, 0. Let's okay, so here you have the x-axis and you have the y-axis. So this is the 0, 0 point, and here you have the x-axis, and here you have the y-axis. Okay, and this is the 0, 0. So here you have a line. You can see that we have 2 points. The first point is at the position 0, 0. The second point is at the position, so at the x-axis, we have here 100. Axis will be 2. So the output or the result will be this line from the point 0, 0 till the point 100, 200. So this is the x-axis. So you have 100 over the x-axis, and you have 200 over the y-axis. Okay? Any question about this?
Assalamu alaikum, Doctor.
Alaikum assalam wa rahmatullahi wa barakatuh.
Can you please show us how open Java graphic in IntelliJ?
Into?
In IntelliJ.
No, here in this, for this course, we are using this skeleton. We are using the NetBeans, okay? So please, even for the TMA, try to use the NetBeans. Okay, so the skeleton that you have here, the skeleton that the file that you can download from the CNMS, they are NetBeans file. So try to use the NetBeans, okay? Because you have many files, you have almost 10 or 12 projects that you can download from the CNMS. And all of them, they are NetBeans file or NetBeans project, okay? So if you return back here, you have many files. So in lecture 2, you have some files. Lecture 3, you have some files, etc. Okay. It's the link. So here we have sheet with answers. So here you have some sheet with answers. And here we have some example of codes. So this is the skeleton that we downloaded. We have the parametric equation. We'll see this parametric equation at the end of this class. We have parametric equation. Here we have rain animation. You have an animated clock. We have printing example. We have a game. We have animation thread. We have here animation skeleton time. So all these, they are NetBeans projects. Okay, so we can open any one of them. For example, animated clock. So this is the animated clock. Let's move it to our folder. Now you can open it here. You can close the project. You can open the new project. You can see here of the animated clock. You can directly open this project. So you can see that here we have clock. So we see how to design a clock like this, how to make an animation. You can see that here we have movement of this rectangle every 1 second. So all the files that you have are NetBeans files. So please try to use NetBeans. Is it okay? تفضل. ممكن تعلي الصوت شوية؟ بالضبط. بالضبط. خلينا I will show you some examples. Okay, let's close this. Let's open project, which is skeleton 0 test. So here the program starts from here. So let's suppose, okay, let's run this. Give me the code to draw something like this. Let's use the epic pen. Okay, I have to use this first of all. Let's use the pen. Now we have the first point here at the coordinate 0, 0. The point here has the coordinates for the x 100 and for the y it is 200. Let's suppose that I want to create a line like this and a line like this. Let's suppose that here the distance is 300. And here we have a distance of 100 and here we have a distance of 200. Yeah, we have already the coordinate of this point. Let's call this point P0. Here we have P1, P2, and P3. Yeah, what is the coordinate of P2 here? For the x-axis, what do we have? For P2, for this point here. For the x-axis, we have already 100 plus 300. For the x component, we have 400. What about the y component? What is the value? Yeah, try to participate. The y component of P2.
500.
Which is the same as the y component of P1, which is
200.
200. Okay, and what is the coordinate of P3? What about the x component? We have here already 400 plus 100. 400 plus 100 equals to 500. And what about the y component?
I think 0.
0. Very good. Yalla. We have seen the instruction to write this line. Now we want to write this line, and we want to draw also this line. So the coordinates that we have here are 400, 200, and you have also 500. 0. So how to change the code to do this? So here the instruction to make a line is G. G is the graphic component, okay? So we can use G or G2. So what is the G2 here? G2 here we are making a casting of G to make it graphics to G. Okay, so we can make here G.draw line or G2.draw line. So here we are using the AWT package. To draw a line, to draw a rectangle, to draw an oval, we are using the AWT. How to draw another line? So same thing, G.draw. Now for the draw, you can draw an image, you can draw a byte, you can draw an arc, you can draw polygon, you can draw a rectangle, you can draw a string. We'll see some examples, okay? Now we need to draw a line. So L should be capital. So here you can see that we have to give x1, y1, and then x2, y2. So draw line. Now the first coordinate will be the coordinate. Now we want to make the second line. What is the first point? P1. What is the coordinate of P1? $200. And then the destination point will be P3. What is the coordinate of P3? Or P2, sorry.
400.
200. That's it. So this will create this line from P1 to P2. Now we want to create another line from P2 to P3. So same thing, G, or we make G2. Dot draw line. Same thing. You can use G or G2. So draw line. And then now we want to make a line from P2 till P3. What is the coordinate of P2? 400. 200. Which is the coordinate of P3?
320.
Very good. Now we can run this. You can see that we have this shape. Okay. So here we have P0. Here we have our P1. We have our P2. And here we have our P3. Is clear?
دكتور
Yes.
ايش الفرق بين
Yes.
draw line و draw string؟
Draw string will draw a string. String يعني string of character. Let's create a string. Yeah, let's create string and let's see how to draw string. Now let's create string. String, for example, let's call it S equals, and let's make it hello. Welcome to Tm240. So this is our string. Okay, semicolon. And now we want to draw this string. So we can make here G2 or G dot draw string. So what do we have to give here? We have to give the string, the str, and x and y. X and y are the coordinates where to put your string. Okay, so let's give here, for example, so what is the string that you want to use here? Want to use the string s. And what is here the x component? Let's make it, for example, 100 for the x component, and let's make it 100 for the y component. So this will draw the string. So I have to close this. Now I can run. You can see that you have here the string hello, welcome to Tm40. At which position? At the position 100 for the x component.
اوكي شكرا دكتور.
Yes. So here you can see the coordinate would be of this point, okay? So here you can see that you have 100 of this component, and you have 100 of the y component, and this is our string case. Is it clear?
كلير شكرا.
One. We can draw, for example, rectangle. Let's create a rectangle, for example, from this point, and let's have 200 here and 100 here. So to do this, we have to use g.draw rect. And for the rectangle, we have to give the coordinate of this point, which is the upper left corner, and then we have to give the width, and you have to give the height of the rectangle. So what is the coordinate of this point in this example? 100, 100. What is the width? 200, which is the height. Let's make it 100. Okay, so let's try this. So here we have to make g.draw rectangle. So the R should be capital. So you can see that we have to give the X and Y the coordinate of the upper left corner. Then we have to give the width and we have to give the height. Yeah, what is the coordinate of the first point? 100.
100.
100, which is the width?
100.
200.
Which is the height?
100.
Very good. So we can close this and run. Now you can see that you have this rectangle here. Okay. So we started the rectangle from this point. So this point has the coordinates 100 from 100. We have here a width of 200, and you have here a height of 100.
دكتور في الاختبار بيعطونا الرسمة وحنا نكتب الكود.
ممكن يديك رسمة ويطلب منك الكود، ويديك رسمة ورسمة ثانية ويقول لك ايش what do you have to change to find the second drawing, for example. Okay, or he can give you the code and ask you for the drawing. It depends.
Okay.
So let's remove the lines that you have here. Let's remove the strings. So I've seen how to draw a rectangle. We can draw also an oval. So same thing for the oval. If you want to draw an oval, you have to give the upper left corner. Okay, you have to give the coordinate of this point. And same thing, you have to give the width and you have to give the height. So if we need here an oval at the point 200, 200, and we need a width of 250 and a height of 50, for example. How to do this? G.draw, and then we have to draw an oval. So here we can use oval. So I can see that we need here X and Y. X and Y are the coordinate of the upper left corner. And then we have to give the width and the height. Okay. So what is the coordinate of the upper left corner?
200.
200.
Yes. Okay.
200.
What is the width?
200.
250. What is the height?
250.
50. Can run. You can see that you have now this oval. Okay. So in this oval, what do we have? We have the point. So we started here with the coordinate 200, 200. So this is the coordinate of the upper left corner. And then we have this width, which is 200, and we have this height, which is 100. Okay. You can draw, for example, a round rectangle. You can draw a string. You can draw a polygon. So to draw a polygon, we have to give a polygon. We have to prepare a polygon, and the polygon means nothing but a list of points that we can connect together. So if you connect a different point here, we'll find the polygon. So we'll see in the next chapter how to prepare and how to draw a polygon. Okay? Any question? Okay, let's draw a round rectangle. So here we have to give x and y. X and y are the coordinate of the upper left corner, okay? And then we have to give the width and the height. And then we have to give, so what is a round rectangle? It is a rectangle. But for the corner here, we have a round corner. For the round corner here, let's suppose that there is a circle. There is one diameter here over the x-axis, let's call it d1, and one diameter over the y-axis, let's call it d2. So in this example, it is a circle here, so d1 equals to d2. You can have something like this. This is a rectangle, and you have rounding like this. So to find the rounding like this, so it's like having here an oval, and this is d1, and this is d2. You can see that d1 is over the x-axis and d2 is over the y-axis. Okay, so if d1 is not the same as d2, so here we have a quarter of an oval. If d1 equals to d2, we have a quarter of circle. Okay, now here we have 6 parameters. So the first one, let's make it the point 300, 300. Let's have a width of 100, and let's have height of 120. Now I have to give d1 and d2. Let's make d1 equals to 30 and d2 equals to 30. And this is the result. I can see that here we have a round rectangle. So what are the parameters that we gave? We gave the coordinate of this point. Okay, we gave this width. We gave this height. And we gave here the d1 and d2. These are the diameters of the oval. Clear? So here we are using the AWT package. Okay. Any question about this? Yes. Let's close this and let's continue. Don't need this anymore. So this is an example of code. Now, Java 3D. So what we use right now is Java 3D. So we're using the AWT package. Okay. So abstract window toolkit. So Java 3D here, we can make 3D graphics, including advanced features as animation, as 3D interaction, and sophisticated viewing. So if you want to do this, you have to use the Java 3D. So it is high-level API. So here the scene graph contains complete information about the virtual graphic world, and you can have some visual effects, etc. So we can apply some transform, we can add lights, we can add a background, we can change the appearance, we can have 3D text. So all these can be done by using Java 3D. And the rendering of the scene is done automatically by the Java 3D engine. Okay. This is called the Java 3D. So in this course, we'll focus on the 2D graphics. Okay. Now we have done for the first lecture. So let's start now the slide of the second lecture. So the second lecture here is for basic primitives. We started already some basic primitives. We have seen how to draw a line. We have seen how to draw a rectangle. We have seen how to draw an oval, how to draw a circle. So if you want to draw a circle, you have just to make the height equals to the width. Okay. Now, at the end of this course, we will see parametric equation. How to make parametric equation. We'll see what does it mean parametric equation, and then we see how to make parametric equations. Now, the objectives of this course are to understand the architecture and operation of 2D graphic system. It's not working. Okay. So the objectives are to understand the operation of 3D graphic system. And here we are using the AWT, as I said. We have to understand the 2D coordinate system and the equation of graphs. So if you make a graph, so generally you are describing the graph by an equation. Okay, because there are two options to create a graph. So if you open, for example, an image, one image on Adobe PDF or Acrobat Reader, the other image is the JPEG image. What's the difference between them? Let's suppose that you have here a ball or a circle in yellow. Okay, the first one is JPEG image, the second one is PDF image. Technically, what is the difference? Or here, if you are using, for example, Illustrator here, Adobe Illustrator. And here you are using Adobe Photoshop. What is the difference between this image and this image? Very good. So in the first image, so here we are describing the pixels one by one. We are giving the coordinate of this pixel, red, green, blue, the coordinate of this pixel, the coordinate of this pixel, etc. Whereas here, if you want to use Adobe Illustrator, or if you want to use CorelDRAW, or you want to use PDF file, so here we call it vector image. What does it mean vector image? So here we are just giving here the equation, and in the file, probably you can see the size of this file is smaller than the size of this file. Because here we have just to describe, we have to say that there is a circle at this coordinate with this diameter and with this diameter, and the color is yellow. That's it. Okay, so it is called a vector image. So I'm describing the shape by using equations. That's why here, to reduce the size of the images, we try to use equations. Okay, so the order that we gave in the previous example, we are asking here Java to draw an image, to draw a line. You can ask Java to draw a rectangle. You can ask Java to draw an oval. Okay, so the program to draw the oval is a very simple program. We have just one instruction, and here Java will convert this instruction to an equation, and then we can draw this equation. Now let's see how Java find the equation of a line or equation of an oval or circle, etc. So this is what this means. We'll see the equations of the graph, and you'll see the standard equation, and you'll see also the parametric equations. So the objective also is to be able to identify the various coordinate systems. So we see the different coordinate systems to understand the Java 2D program structure and the graphic 2D object, and to understand the graph equation with Java program, and we see the basics of 2D geometric primitives. Now, what are the primitive geometric objects that we can have? So to create a line, so I've seen that we can use a line, but to create a line, we need 2 points. So here the basic primitive objects are the points. So we can start with a point. And in Java, we can define a point. So how to define a point? We can have point P, and then we can give the X coordinate and the Y coordinate of the point. Okay, then if you have 2 points, P1 and P2, you can generate a line. So a line is described. So we can have a line or a polyline also, or you can have also curve. So line like this, curve can be like this. So for the first one, for the line, you have just to give P1 and P2. For the second curve, you have to give P1, you have to give P2, and you have also to give here a control point. Let's see, call it C1, which is the control point. How to change the first line to make it as a curve. So we'll see this in the next slides. So here the line, they are can be defined by using 2 points, and the curves can be defined by 2 or more than 2 points. Okay, so for a line we need 2 points, but for the curve we need additional control point. You can have 1 control point, you can have 2 control points, etc. We can have also polyline. So polyline means many lines that are connected together. This is polyline. If you have a closed or bounded polygon, so here we have what we call the area. And if you have the area, for this area we can add color. We can add here texture. We don't have a texture for a line. For a line, we can just give a color. But if you have an area, we can add a texture. We can add the transparency. Okay, so this is if you have an area. So it is an area, it is a bounded area that is closed and bounded area. So it is closed by using different lines, okay, or polylines or polygons. So the area can be filled with a color or can be filled with texture. Now, after making the modeling, we can make some transformation. And you have 2 types of transformation. We have seen that you have the object transformation and you can have the viewing transformation. The object transformation changes the shape and the location of the visual object. Transformation will be applied to the object itself. Whereas the viewing transformation will not change the virtual world model. So the virtual model is the same, but it will change the scene that you are displaying. It is changing here the rendering process or the scene that you have in the rendering without changing the virtual world. Okay, so as an example, in virtual model with a circle and triangle, let's suppose that you have a virtual world. We have a circle and we have triangle. Okay, the translation is applied to the circle as an object transformation. If we make transformation of the circle, for example, we are just making a translation of this circle. Okay, so this will move only the circle without changing the rectangle. But if we make a translation as viewing transform, in that case, the entire scene here will be changed. And if you translate viewing, if you make a viewing transform of translation, you are translating both. You are translating the rectangle, triangle, whatever it is here, and the circle also. Well, Shabab, you have to know what is the difference between object transformation and viewing transformation. Viewing transformation will transform the whole virtual world, and the object transformation will transform only this object. For the object, you can make a rotation, you can make translation, you can make shearing, you can make any type of transformation. And you can also apply the transformation for all the objects by applying the transformation on the viewing. So it is called viewing transformation. Now let's see the coordinate system. So in math, generally we are using the Cartesian coordinate system. Well, let's see Cartesian coordinate system. We have the x-axis, we have the y-axis, we have here the 0, and then we can have here points, we can have curves, we can have anything. So it is called the Cartesian coordinates. We can have also the polar coordinate. So for the polar coordinate, what do you have? So for the Cartesian coordinate here, for every point, let's suppose that here we have P0. So we can describe this P0 by giving the x component and by giving the y component. In the polar coordinate, so here, let's suppose that we have here our P1 is here. So we can describe this point by giving here the radius between the axis and by giving the angle theta. So in polar coordinates, we can describe any point in the space by giving r and theta. So let's suppose that our point is here. So we can define our r here and we can define this. So this is called the polar coordinates. Now let's see the description or how we can express a line. Okay, so a line can be represented by a polynomial with degree 1. So ax plus by plus c equals to 0. So this is the equation of a line. Now the equation of a circle or of an ellipse. So for the circle, we have this expression x squared plus y squared equals to r squared. And r here is the radius of circle. So this is our r from here to here. If you have this expression, this will give you a centered circle. And the center or the origin of the circle here is at the position 0, 0. Now, if you want to change this circle, you have to make it an ellipse, and the center is not at this point. That is, we can use this formula. So x minus x0 squared over a squared. So a here is the radius of this ellipse. So for the ellipse, we have two radius. We have r1 and we have r2. So this is the radius, the second radius, which is b. And then we have x0 and y0. These are the coordinates of the center of this ellipse. So you have the point, the origin, and the coordinate x0 and y0. So this is the expression of an ellipse. So generally, if you have an expression like this, so you can see that here we have the unknown are x and y. So if we know x, we can calculate y. Same thing here. If we know x, we can calculate y. So generally here we have an expression which is y equals f of x. And how to draw this? We can have a table. So let's have here x and y. If you have this value for x, for example 3, we can calculate this value of y. This will give you the first point, P1. With the coordinate, let's see, for example, 3, and here we have 4. Now, if x equals 5, we have this value. We can calculate it by using the formula. X equals 10, we can have this value, etc. And then we have different points, P1, P2, P3, etc. And then we can join the point together. Suppose that these are the points, so we can join the points to find f. Okay, so if you have a line with just 2 points, for example, let's suppose that you have the equation y equals 2x plus 4. So it is an equation of degree 1. So we can have 2 points for x, and so this is x, this is y. Now, if x equals to 0, so y will be 2 times 0 plus 4, it will be 4. If x equals, for example, 3, we have 3 times 2, which is 6, 6 plus 4, which is 10. Now I have 2 points. We have the first point, 0 and 4, to be here. For example, the second point is a 3, 10, probably here. And then we can connect the 2 lines together, or the 2 points together to find the line. This is for the line. Now for the circle or for an ellipse, we need more points. So same thing here, we have the expression of y equal f of x. We can have many points. This is x, this is y, and then we'll have different value for x and calculate the corresponding value for y. Now the second type of equation is the parametric equation. In the parametric equation, we have here a third variable. You don't have x equals f of y, you have x equals f of t, and y equals f of t or g of t. You have another function. For example, for an ellipse, the parametric equation is x equals x0 plus a cosine t, and y equals y0 plus b sine t. In that case, if you want to draw it by hand, how to do it? So here we have to make a table. So the unknown here are x and y. And for every value of t, we can have a value of x and y. So for example, we can make t equals 0, we can have here x 0, and we can calculate y 0. Since we have here the expression, if t equals 0, we can find x 0. If t equals 0 here, we can find y 0. Then t equals to 1, we can find x1, y1. Then t equals to 2, we can find x2 and y2, etc. And then we have the different point. We can join the different point together. We can find our shape. So this is called parametric equation. And we see in this class how to make parametric equation. So you can see here that we are creating the shape by doing what? By just joining the different point here. So we calculated the first point. So for t equals 0, we have the first point. Let's call it P0. Okay, and then we change it t. Now t is 1. We have the second point, P1. So you have P0, and here we have P1. And then we made a line between P0 and P1. That's it. And then we have to repeat the same thing. Now we have to calculate P2, and then we have to make a line between P1 and P2. Then we have to make a line between P2 and P3, etc. So if you join the different points, you'll find the shape that you need. So if you have many points, you have a smooth curve. For example, let's suppose that you want to make a circle by using 3 points. It will be triangle. So let's suppose that you want to make a circle with 10 points, so it could be something like this, etc. So as you increase the number of points, you are increasing the resolution or the smoothness of your circle. Now, generally, we have here 3 types of spaces. We have the object space, we have the word space, and the device space. So the object space here is the space of the object itself. It is here local to the object. So it is also known as the local or modeling coordinate system, because if you have an object, this is the space of this object. So it is local to this object. So it is associated with the definition of particular graphic object. So it is the space of the object itself. Okay. Now, in constructing such object, it is usually convenient to choose a coordinate system that is natural to this object. For example, if you want to design a circle, we can make the origin, which is the center of the circle, as an example. Okay. So if you want to, for example, rotate a circle, don't make the center of rotation here, for example. So if you rotate the circle, it will be here. So it depends on the application that you need. Now, this is the first space, which is the object space. The second space is the word space. Word space means the space of your whole words. Okay, so it is known as user coordinate system, which is a common reference to place all the objects. For example, here I have to place 2 rectangles and 1 circle. So here, to place this rectangle, I need a coordinate. For example, here, coordinate for the word space. I need to make the second object. I need the coordinates where to put the second object in this word space. I want to put this circle here, so I need here. So to put the different item in the word space, or in the virtual world, here we need to use the word space. Okay. So the geometric object here are placed into the space through the object transform. So if you want to move this circle, we can move it, for example, to the left, to the right, etc. The last type of space is device space. So the device space here is the, so in Java, we are using here the device space, which is the same as the screen space. So here, which is the device or the space of the Java panel. So when we run a code, we have here a panel. And in panel, the space is, so we can see that here we have the position 0, 0, and then we have the x-axis from here, and then we have the y-axis from here. So this is called the device space. So it represents the display space. So how the graphic is displayed in the output device, like the screen or printer or whatever. So if you run the code, so here we'll have the applet here, this applet, and then here we'll have the space, choose the device space here. Will be the position 0, 0, here we have the x-axis, and here we have the y-axis. Okay, so this is the space of this applet, which is the same as the device space, which is the space that is displayed on the screen. So this type of space, it is called the device space. Now, the Java of the graphics 2D class. So in Java 2D, the rendering engine is accessible through the class graphics 2D. So previously we used the graphics and the KWT, but we can make here casting to graphics 2D. So the graphic class contains basic methods for rendering graphic primitive. Java 2D. So in Java 2D, we are using more extensive graphics 2D class for the rendering. Yani, the graphics 2D extend the graphic to maintain compatibility with earlier AWT. So here in the code, you can see that here we are making graphics 2D, G2 equals. What are we making? We are making a casting here of G. So what is G? G here is graphics object. So the parameter of the paint component here is G, and G here is graphics object. We are making casting to graphics 2D. So G2 here is graphics 2D object, whereas G is a graphics object. So here for G, we are using the AWT, and for G2 here, we are using the graphics 2D. And it is compatible. So here we can make G dot draw. We can also make G2 dot draw because graphics 2D is compatible with graphics with the AWT. So if I make G2 here also, it will work. Same thing, because graphics 2D is compatible with the AWT. But Java 2D uses more extensive graphics 2D class for the rendering. And the graphics 2D extend the graphics to maintain compatibility with AWT. And graphics 2D and the graphics class, they are abstract, so we cannot instantiate them directly. That's why here, the way to retrieve an object here is to use the paint component. So we can obtain the graphics here as a parameter of the paint component. That's why here we are putting the code in the paint component. Now, let's see some examples of using graphics and graphics 2D. So here in AWT, we can draw a line, we can draw an oval, we can draw a rectangle, etc. And let's draw this code or this shape. So what is the instruction that we need to draw this shape? So what do we have here? We have 1, 2, 3, 4 lines. So here we can use G dot draw line directly. Okay, so the first line can be, for example, from this point to this point. So we can have here P1, P2, we can have P3, we can have P4. The first line is between P1 and P2. The second line between P1 and P4. The next line between P2 and P3, and the last line between P3 and P4. So here I have used just G dot draw line. So how to test this? We have to go to the skeleton. We have to find the skeleton. We can download the skeleton from the CLMs. Yeah, what is the first point? What is the first point? 30, 30.
30.
30, 30. Let's go to this point, or let's go to this point. Let's make it 200, comma, 200. Comma, 200. Then we have another line. So G dot draw line. Now, what do you have?
200
start.
200.
Okay, let's continue with the P1. So we have 30, 30. Then we are
230.
going 150. That's it. So I can check what we have. What's the Okay, so we made the first line and we made the second line. Let's continue. So here you have to make from 230 till 30, 200. So G dot below line from now 200,
230.
30 till
30.
30,
200.
200, and the last line
30. 30. 230, I think.
last line will be this one from 30 to 100 till 200, 200. 30, 200, till 200, 200. So you can check this and you have this check. Okay. Any question about this? Okay, so here try to focus on this remark. So in AWT, there is no separation between the modular and the renderer. Yani, what we did here, if we use draw line, we are making at the same time the modeling and we are at the same time displaying the line. We are modeling the line and we are displaying, we are rendering the line at the same time. Yes or no? So same thing, if we draw an oval, so at the same time we are making the modeling of the oval and we are displaying this oval. Okay? In graphics 2D, we don't work like this. In graphics 2D, there is a separation between the modeling and the rendering. Yani, first of all, we can make the modeling. I can design, for example, an oval without displaying it. And then I can have another method or another function that I have to call for rendering or for displaying this oval or for displaying the line or whatever. Okay, so for example, to draw an ellipse, we can create an instance of ellipse 2D. So we can create an instance of ellipse 2D, which implement the shape interface, and then we can call the draw method to make the rendering. Okay, so here, what are we using here? AWT or graphics 2D? Very good. So here we are using AWT. Why? Very same time modeling and very good. So we'll see in the next presentation, the next class, inshallah, how to use the graphics 2D to separate the modeling and the rendering. Okay. So at home, Shabab, try to make the digits, for example, 1, 2, 3, try to draw these digits. You can have, for example, 1 like this, and draw the 0. You want to make the 0 like this. Try to do the 2, etc. Okay. So try using only the function draw line to plot the 10 digits from 0 till 9. So as an example here, we have the 2. You can do something else. You can do, for example, the letters A, B, C, D, E. Sorry. For example, you can draw the letter F. So let's see how to Okay, let's suppose that now we want to make the letter. So how to draw this? So first of all, we have to give the coordinate, for example, of this point. Okay, let's use, for example, 100, 100. Let's use here this distance. Let's make it as 100. This distance, let's make it as 100. The same as this distance here. Let's make it 50. Yalla. Give me the coordinate of the different point. What is the first point? Okay, what is the coordinate here for this point? This is P1. P1, 100, 100. P2, let's use P2 here.
200, 100.
Very good. 200, 100. P3 here.
100, 200.
100 for the X component and 200 for the Y component. For this one, P4.
100,
150.
Okay, for the X component, we have 150. Yes or no? We have already 100, and then we are adding here 50. And for the Y component, Y component.
300.
200.
200. We have already 100 here, and we are adding here this 100. And for this point P4, okay, for the X components, what do we have? 100. And for the Y component, we have already at the beginning 100, then we are adding 200, so it is 300. So once we have all the coordinates, we can start our works. Okay, so we can make the first line like this, G2 dot or G dot draw line, and then we give the coordinate of the first point, then the coordinate of the second point, and then semicolon, etc. Okay. على حسب الاختبار مفروض تقريبا. تفضل. ايوه حسب السؤال. اوكي. يلا we have here draw line, which is the first point here, 100, then 100, then 200 and
200, 100.
100. And the second line, the horizontal one. What is the first point? 100, okay.
100.
Then for the X component, 100 again, and for the Y.
200.
Okay, now let's make the next point P3, 44. What is the X component? 150.
150 and
Okay, let's start with the last point, 100, 200. And for the Y component, 200. Then for the second point, 150. And then we have 200 for the Y component. And then the last point, here, 44. We start from here, 100, 200. Then the last point will be 100, and then 3. numbers. So here we made 1, 2, 3, 4 line, but we can make also here just one line from 100, 100 till this point, which is 100, 300. Yes or no? So you can see that now we have the letter. So we can do it by making just three lines. We can have one line here, one line here, and another line here. Okay. At home, try to make the A, the B, C, etc. Okay. But to make here the B, we need curves, and we haven't seen how to make curves. We see how to make curves in the next translation. Okay. Now we have seen how to create. If you have an equation, for example, if you have a line, okay, so we can have two lines and then we can connect the two lines. But for the equations, if you have just a single equation like this, the order is 1. So if you have, for example, y equals f of x, and here have f of x is, for example, ax plus b, we can select 2 points and then we can connect the 2 points together. Okay. Now, if you have here a parametric equation, so if you have an expression like this, for example, f of xy equals to 0, or f of xy equals to a or b or c or whatever. In that case, you cannot make the 2 points. You cannot have here x and then calculate the y, because here you have f of x, y. In that case, it's better to implement or to add a third parameter. And here we are talking about parametric equation. So here we have to convert this problem to make it x equals f of t and y equals f of t. Okay, so here we have the equation of x, the equation of y, x equals r1 plus r2 cosine t minus p cosine r1 plus r2 over t divided by r2. So here we have x equals f of t. We know r1, we know r2, we know r1 and r2. So here the unknown variable is only t. So here it's like having a table. We have t for different values of t. We have to calculate x and y. T equals 0, we have to calculate this value. T equals 1, we have to calculate this value. And then we have to make a line between P1 and P2. And then I have to have another value for t. Okay, for example, we have 2, we have this value for x, this value for y, and then I have to make a line between P1 and between P2 and P3. To make it as an algorithm here, we can call here P1 and P2, and then we can make a line between P1 and P2. This is P1 and this is P2. Then for the next step, we can change this P2 to make it P1 again. And here we are calculating the new value of P2. And then we can make a line between P1 and P2. We are changing P2. Now, after drawing this line, okay, we are changing the value here. This will be P1. We have to calculate P2. And then we have to make a line between P1 and P2. And then this P2 will be P1. Then we calculate P2. And then we make a line between P1 and P2. So this is the idea. So this is an example of program in which we are using here a parametric equation. This is the spirograph equation. So you can find this code on the CLMS, or you can make just copy paste of this code. So let's copy from here. We are using set color. Of the 4, and we are closing the 4 here. So where to place this code? Just here, after the parent component. Let's paste the code Okay, so G2.set color, we are using the color blue. So this line is just to change the color to make it as blue. Then we have R1, R2, and R3. We have the number of points. We are using 1000 points. And then we are calculating the initial value of P1. So we have to find here the initial value of, for the P1, we have to give X1 and Y1, okay? And then we have to calculate X2 and Y2. So these are the coordinates of the second part. So here we give the, let's call it P1, okay? And here we have P2. So initially we're starting with P1 and then we have to calculate P2. How to calculate P2? We have to find X2 and Y2. And we have to repeat doing what? Repeat doing the calculation of X2 and Y2. So this is the expression of X2 and Y2. And drawing the line between P1 and P2. After drawing the first line, this is P1, this is P2. After drawing the first line, we have X1 equals to X2. That means now the new P1 is here. And Y1 equals to Y2. So this is the new P1. And we have to change the value of T and then calculate now P2 again. After calculating P2, we have to draw the line between P1 and P2, etc. Okay? So let's correct this code. Here we have a triangle, we don't need it. So this one, it's for the page components. Okay, so what do you have here? We have the same shape that you have here. You have this shape. So we designed this shape, but we cannot see this shape. So what can we do to show the whole shape that here? Translation, very good. And how we did this shape? How many lines do we have here? We have 1000 points. And we connected these 1000 points together. That means here we have how many lines? 999 lines. Do we have to translate all these lines? So if we translate these lines one by one, we are making the object transformation. But now I want to translate all the lines together. What do you have to do? What is the second type of translation? It is the viewing translation. And you have to apply the translation for the whole graphic, not for one object, not for one line, but for the whole graphic. So here we can translate the whole G2. So here what do we have? What is our graphic here? Our graphic is G2. I'm using here G2, the color. What you have here, we apply the color for G2. And here we are drawing the line in G2. So our object is G2. So we can translate the G2. So here we want to translate the G2. You can see that here we are applying G2.translate. We are translating 200 to the X component and 200 to the Y component. Okay, here G2 dot translate. And then we have to give the translation over the X-axis and the translation over the Y-axis. Let's make it 200 on the X-axis. Let's make it 250 on the X-axis and 250 on the Y-axis. Now you can see that we have this shape. So how we did this shape? We made how many lines? We made 999 lines. And all these lines are connected together. One line here, one line here, etc. Is it clear? Can we change the number of points? So let's make the number of points instead of 1000, let's make it 100. And let's see what do we have as a result. We have only this part of the spiral graph. Let's make 200. We are completing the spiral, etc. Let's make it 2000. we have this spine one. Okay. Now we choose here this number 1000 because here we are making rotation, okay, with certain angle. And what is the rotation angle here? What is our T? T here is I, which is the value that you have here. Are changing the I. So I is from 0 to T, the number of points. It's still the number of points, 1000. Okay. And what is the angle phi that we are changing? So it is I multiplied by pi divided by 90. Okay, so here we have the first value of I, which is 0. We have to calculate T. From T, we calculate x2 and y2, the point P2. And then we draw the line between P1 and P2. And then we increment the I will be 1. And then we calculate the T. T will be 1 multiplied by pi divided by 90. And then we calculate P2 and then we draw the line. It's simple. Now, if we change the values of R1 and R2, let's make it, for example, 30, and let's make 25 for P. So let's see what we have as a shape. You can see that now we have another shape. Okay, and change this P, you can make it 70 again, and check the shape. You see that we have another shape, etc. So as you change the values, you are finding new shapes. So this is an example of parametric equation. Is it clear? Any question about this? فالفكرة هنا إن نبغى نسوي 280 درجة بالنسبة للتي. كيف 280 درجة قسمناها على 1000 نقطة. لا هنا على حسب الايكويجن اللي عندك، فتكتب من الايكويجن إذا تي من 0 إلى 2 باي. اوكي فهذه الفكرة. ايش الرسمة اللي بعدها؟ So, any question about this slide? No questions. Okay, so here we have another equation. So same thing, here we have x equals f of t and y equals f of t, and here the t is between 0 and 12 pi. So if we change the value of t, so this will change the shape. Okay, so we'll complete, you'll find the complete shape if the t is between 0 and 12 pi. Okay, so this is the equation. So if you have x equals a cosine k, x multiplied by t, and y equals b sine k times t, you will find another, etc. So let's suppose that we want to test this plot. What to do? We want to test this plot. Or we want to try to plot the Lissajous curve. What do you have to change in this program? What do you have to change in this program? Here we go. Just to change x2 and y2. Okay, so the curve or the 4 here will be the same. So what do we have in this 4? We have 4I from 1 to the number of points. Okay, and then we are calculating the T, and then we have to calculate P2. So here we have to change the expression of X2 and Y2, and then we have to draw the line between the point P1 and the point P2. Okay, let's see this in the next class, inshallah. Any question before leaving? So here in this example, or in this example, if you change the parameter, you will have another shape. If you change Tx and if you change Ky, you will find other shape. Okay. So here we have other examples of parametric equation. You can try this equation at home. So we have the expression, and then you have to just change the expression of x2 and y2. That's it. The rest is the same. You can try this at home. In this class, we will try the stages curve together, and then we'll start the next lecture. Any question before leaving?